In the last example from the packet, in a very similar to example number 9, we're going to talk about a sinking fund. So a sinking fund is a fund which periodic payments are made in order to satisfy a future obligation. So suppose a company vehicle which costs $75,000 is to be replaced at the end of 7 years, which at that time it will be valued for salvage at $10,000. So imagine we're buying a company Escalade. We're going to plan to use it for 7 years. Um, and then after we're done, it's going to be too old and we're going to want to get rid of it. So we're going to salvage it for the remainder. And we want to know when we have to replace it. Let's assume that we have to pay $75,000 at the end of that period of time. We want to know how much money should I be putting into a sinking fund in order to generate enough to have at the end of that 7 years. And again, it's assuming interest is gonna we're gonna be getting interest on this. So basically, what we're looking at here is the future value of an annuity, because we want to pay a bunch of money month by month by month into an account in order to generate this financial goal, the future value of. In this case, we want to gain $65,000 because we're going to need 75K, but we're also going to get 10K back from our salvaged vehicle. So, and this is very similar because we're trying to figure out what is the payment amount, just like example 9. But we're going to be dealing with future value because we're looking at a future payment. And the key difference here is that in example 9, we had this money up front to purchase an annuity. Here we are investing into annuity in order to generate a future obligation. And we want to know how much should we put in every month. Very, very useful actually for financial matters to this exact example. But again, we could start with the formula that capital S is equal to R times little s n bar P, where everything is known in here except for R, the payment amount. And again, we could find R by dividing both sides by little s n P and plug in everything in much the same way. Here, our sinking fund, which is probably what S stands for, is we're gonna want to generate 65,000 total amount of money in the future. Remember, capital S is the future value of the annuity. That's what we want it to be, which is just the difference in how much it's going to cost us to how much we're going to get from salvage. And we need to divide by SNP, where again we obviously want to know what is N and what is P. So in this case, it looks like I've continued to use 6% compounded monthly, leaving our periodic interest rate at 0.005. And since it's 7 years compounded monthly, that total number of periods is going to be 7 times 12, which is 84 total payments. So in our formula, we're going to take S and divide by SNP, which is this friendly, fun fraction here. That was very alliterative. And then, so we're going to basically be dividing by 1 plus p to the n minus 1 over p. So divided by 1 plus p to the n minus 1. And then that whole thing again, just like I said before in the previous video, would be divided by p, which if I'm dividing by a division would flip to multiply and leave me with that times that. It's like that one up there was times by p. Or again, you could calculate SNP first, then just take 65,000 divided by SNP. But as I've been warning you guys about, be careful with your rounding, because if you round before doing another calculation, the rounding will again compound, which is why I like to type in the whole thing all at once when I do it. So I'm going to use parentheses around the bottom because I'm dividing by multiple terms. And if I don't, it will not be right. Anyways, that would give me the value of the payments into that sinking fund rounded to the nearest cent will be $624.56, which if I make that payment every month for 84 months, assuming compound interest, our sinking fund should have exactly $65,000 at the end so that we will have enough to buy our new Escalade. So it gives us like a financial goal um, for for future expenditures where we can obviously not be hit with it all at once.